Hello friends, a very good morning to all the students. Am I audible perfectly? Okay, fine. So getting your responses in the chat box. So dear friends, if you remember, we are discussing one of the important chapter of the subject Basic Mechanical Engineering. The chapter name that is the properties of the gases. And dear friends, if you remember, in the last lecture, we have discussed three non-flow processes. The processes which we have covered in the last lecture, they were, the first one was the constant volume process, also known as the isochoric process. Then we have understood the second process, that was the constant pressure process. Another name of this process is isobaric process. And the third important process we have discussed, that was the constant temperature process. The different names of the constant temperature process are the isothermal process as well as the hyperbolic process. So dear friends, today's lecture will be a power pack lecture. Why I am telling power pack lecture? Because in today's lecture we are going to discuss the last two processes. They are the adiabatic process and the polytropic process. And in these two processes we will be making or understanding several derivations. So before starting the discussion of the current topics of the adiabatic process and the polytropic process, I suggest that you all be ready with the notebook and the pen, so that as I am explaining the derivations, you can easily note down the steps and understand the procedure how to make the derivation. So dear students, let us start with the first topic of this session, that is the adiabatic process. Remember, it is one of the important questions which is generally asked in your theoretical examination. The adiabatic process is a thermodynamic process in which there is no heat interaction. That means during this process, the system cannot absorb the heat, nor the system can release the heat. That means during the adiabatic process, there is no heat interaction. And since there is no heat interaction, we can write down for the adiabatic process, Q is equal to 0. Now considering the first law of thermodynamics, that is Q is equal to delta U plus W. Since Q is equal to 0, I can write down the equation, that is minus W is equal to delta U. So remember, for the adiabatic process, the work interaction is taking place at the expense of the internal energy. So for doing the adiabatic process, if we want to do the work done, then compulsory the work is done at the expense of the internal energy. Because in the adiabatic process, there is no heat interaction or there is no heat transfer. Remember this definition, the frictionless adiabatic process is known as the isentropic process. And it is a theoretical hypothetical process, because whenever we are considering any practical processes, always there will be some amount of the friction. Remember friends, the law for the adiabatic process or the standard equation for adiabatic process is given as PV raised to gamma, that is equal to constant, where gamma is always a fixed value, a constant value that is equal to 1.4, and also the gamma is known as the adiabatic index. If we are representing the adiabatic process on the PV diagram, it shows this type of the curve where 1 is the starting point, 2 is the ending point, and the curve represents the adiabatic process where the standard equation is mentioned, that is PV raised to gamma is equal to constant. And the shaded area which is getting on the PV diagram, that is the work done. Below the diagram, we are seeing that there is one cylinder contain the piston, but the cylinder is completely insulated from all the sides. Because of this insulation, now we can understand that there is no heat interaction. So these are some of the important and basic concepts related to the adiabatic process. Moving further with the next topic of the adiabatic process, that is the law for the adiabatic process. And dear friends, this is one of the most important question which is generally asked in your theoretical examination. Repeating the point once again, dear students, this is one of the most important question which is generally asked in your theoretical examination. So you can start noting down the steps of the derivation so that the answer is perfectly clear in your minds. So starting the derivation according to the first law of thermodynamics, I can write down heat supplied is equal to change in internal energy plus the work done. Very simple statement according to first law of thermodynamics. Now I am considering unit mass of the gas. Since I am considering unit mass, all the parameters will become the specific parameters. And the changes are also very small. So I am using this equation, that is dq is equal to cv dt plus p into dv. You are observing that in this equation, all the extensive properties which are dependent on the mass, they are represented by the small alphabets, whereas the intensive properties, temperature and pressure, they are mentioned accordingly. Now dear students, proceeding further, as we have already understood that for the adiabatic process there is no heat interaction, that means I can write down dq is equal to 0. Substituting this value in the above equation, I will be getting the answer, that is cv dt plus p into dv, that is equal to 0. I hope you have understood up till this point equation number 1, and you have also mentioned all these steps in your notebook. You are writing down these steps. I want your responses in the chat box. I hope you have understood up till here equation number 1. Okay, fine. Thank you all for the positive responses. Now let us proceed further, understand the further steps. Now we are considering the characteristic gas equation. The characteristic gas equation is written as PV is equal to capital R into T, because in the characteristic gas equation we are considering mass is equal to 1 kg. So now I will be differentiating this equation. And for differentiating this equation, I will be taking the logic. Remember this point, that is d by dx u into v. So that is equal to u dv by dx plus v du by dx. But in this equation, we are having 3 unknown parameters, pressure, volume and temperature. So we are not differentiating with any of the specific parameters. So we are neglecting the term, that is x. And on differentiating, we are getting this answer according to differentiation of u into v into dx. So that is u into dx plus v into dx. So I can write down in the similar manner, that is P into dV plus V into dP, that is equal to R into dt, plus there will be one term T into dr, but R is the constant value, so dr differentiation of constant term, that is equal to 0, so no need to write that 0 term. So finally, on differentiating this characteristic gas equation, I am getting the answer P into dV plus V into dP is equal to R into dt. From this equation, now I am finding the value of dt. So dt is equal to P into dV plus V into dP divided by R. Substituting this value of dt in equation number 1. Remember friends this step. Now substituting the value of dt in equation number 1. So substituting that value, we will be getting this type of the answer, that is Cv into Pdv plus Vdp divided by R plus this term, that is P into dV is equal to 0. Now friends, you need to do some mathematical calculations at your level. What you will be doing? Multiplying this denominator R into this term, and this is always equal to 0. Then substituting capital R is equal to Cp minus Cv, Mayer's equation, we have already understood. Then you have to elaborate all those brackets, multiply all those brackets. You will be getting 4 answers. And these 4 answers you will be observing, 2 answers will be the same answers. But one answer will be having the positive sign, another answer will be having the negative sign. So both that terms will be cancelled. So out of the 4 terms which you are getting, 2 terms will be cancelled. And only 2 terms will be remaining. So these are the 2 terms which are left in the equation. I hope you are calculating at your level, and if you are getting this equation number 2, kindly share me your comments in the chat box if you are getting the answer equation number 2 by calculations. Kindly give me your comments in the chat box so that I can proceed further in the derivation. Okay, some of the students have tried and they are getting the answer. Very good. Getting the positive responses from the students. Okay, very good. Majority of the students have got equation number 2. Fine, very good. So now let us proceed further in the derivation. So again, using the equation number 2, now what we will be doing? Dividing the above equation number 2 by Cv, V into P. Remember, this is a small v and this is a small p. This is a Cv, specific heat at constant volume condition. Dividing the equation number 2 by this term. So this is how the term looks like after dividing. Now we are seeing that we can cancel it out, the common terms. So in the first term, the pressure gets cancelled out. And in the second term, Cv gets cancelled out and V gets cancelled out. So finally, you will be getting this type of the answer after making the cancellations. That is Cp upon Cv into dV by V plus dP by P is equal to 0. Now friends, you are well aware that ratio of specific heat, that is Cp by Cv, is equal to gamma. So substituting that value in this equation, and gamma, that is always constant, that is 1.4, also known as the adiabatic index. So now I am getting the equation, that is gamma dV by V plus dP by P is equal to 0. I hope you are getting the answer up till equation number 3. I want your confirmations or the responses in the chat box if you are getting the answer of equation number 3. Very slowly and steadily I am moving in the derivation so that you can easily note down all these steps, and while you are noting down, you can also understand these steps perfectly. Okay, thank you students. Majority of the students have got up till equation number 3. Now what we will be doing? Now we will be integrating equation number 3. Dear friends, remember in this integration, this is a simple integration. We need not to mention the limits of the integration. In simple integration, whenever we are integrating, we can write down gamma integration dv by v plus integration dp by p is equal to integration 0. So I will be getting this answer, that is gamma into ln v plus ln p, and integration of 0, that is a constant term, so I am writing that constant in the form of ln, so I am mentioning that is ln c. I hope you are understanding the points. We are just doing the simple integration of 1 by x dx, that is ln x. So now I can remove this term of gamma and lift over to the head of v. So I can write down that is ln v raised to gamma plus ln p is equal to ln c. So all the terms are having ln, so positive ln can be removed, that comes in the form of multiplication. So removing all those terms, now I will be getting the answer, that is p into v raised to gamma, that is equal to constant. I hope you have understood up till this point equation number 4 and you are getting the answers. Remember friends, in equation number 4, this small v which you are mentioning, that is specific volume, small v. Do not write here capital V, otherwise the complete derivation will be wrong and you will be getting 0 marks. Remember, this is small v, that is the specific volume. I hope you have got the answer of till equation number 4. PV raised to gamma is equal to constant. I want your responses in the chat box so that I can move further in the derivation. Okay, so majority of the students have given me the confirmation. Thank you all. So now this equation number 4 is known as the Poisson's law. Remember friends, majority of the students will be making the error in the examination. This is the equation number 4 which is known as the Poisson's law. And in the Poisson's law, the volume, that is the specific volume. In the adiabatic law, we are seeing we need to have the total volume. That means here it is capital V and here it is small v. So now again we need to proceed further in order to get this final answer. So try to note down this point in your book so that you are not making the error in the examination. This is the equation number 4 which is known as the Poisson's law. So let us proceed further. Now we will be getting our final answer. So let us understand those steps. So PV raised to gamma is equal to constant. That is equation number 4. We have already derived. That is Poisson's law. Now we know that the specific volume, that is small v, is equal to capital V by m, total volume divided by mass, and each unit is meter cube per kg. Substituting this value in this equation number 4, we will be getting this type of the answer, P into V by m raised to gamma is equal to constant. So we will be getting m raised to gamma multiplied by the constant is a new constant, that is again a constant. And now we are getting the final answer of the derivation, that is PV raised to gamma, that is equal to constant. Equation number 5, and this is the answer, that is the law for the adiabatic process. And equation number 5, that is the adiabatic law. If you compare this equation with this equation, both the equations are same. That means this is our final answer. Remember friends, majority of the students are making the derivations up till the Poisson's law and they are not getting the full marks. After the Poisson's law, you need to proceed further by some 1 or 2 steps. Then only you will be getting the final answer for the law for the adiabatic process, that is P capital V raised to gamma, that is equal to constant. I hope you have perfectly understood this derivation. You have understood these steps and also you have noted down the points to remember at the time of the examination or whenever you are preparing this derivation. I want your confirmations in the chat box if you have perfectly understood this derivation and all these steps which we have done to get the final answer. Okay, thank you very much. Majority of the students are giving me the positive answers. That means they have perfectly understood and also they have noted down the steps. So now let us proceed further to the next topic of the adiabatic process, that is the amount of the work done. So we are knowing that standard relation work done is equal to PdV. So total work done, that is equal to integration of PdV between the limits V1 and V2. So now we know that for the adiabatic process, PV raised to gamma is equal to constant. So P is equal to C upon V raised to gamma. Substituting this value of P in this equation of integration, I will be getting this answer. W is equal to integration of C upon V raised to gamma into dV between the limits V1 and V2. C is the constant term, so it is removed from the integration and I will be getting C integration of V raised to minus gamma into dV. For doing this integration, I will be taking the logic, that is integration of x raised to n dx. So that is equal to x raised to n plus 1 divided by n plus 1. But in this case, my x is equal to capital V and n is equal to minus gamma. So on integrating this equation between the limits V1 and V2, I will be getting the answer in this particular format, that is W is equal to C V raised to minus gamma plus 1 upon minus gamma plus 1 between the limits V1 and V2. And for remembering, you can also note down we are using this integration concept for getting this answer. Integration of x raised to n dx, that is x raised to n plus 1 upon n plus 1. Now whenever we are opening the limits, we will be getting the answer, that is W is equal to C V2 raised to minus gamma plus 1 minus V1 raised to minus gamma plus 1 upon minus gamma plus 1, that is equation number 1. I hope you have understood up till this point. Dear students, I want your responses in the chat box so that I can proceed further. If you have understood up till equation number 1 and if you have noted all these steps, then kindly give me the confirmation so that I can proceed further. Very good. Okay, so some of the students are noting down these steps, they are understanding perfectly fine. So now let us proceed further. We are already aware that C is equal to PV raised to gamma. So I can write down C is equal to P1V1 raised to gamma and also that is equal to P2V2 raised to gamma. Now friends, remember this step. When C is multiplied by V2, we will be substituting the term P2V2 raised to gamma. Two terms, make it in common. When the C is multiplied by V1, we will be substituting P1V1 raised to gamma. So I will be getting the answer of the first bracket P2V2 raised to gamma into V2 raised to minus gamma into V2. minus the second bracket I will be getting P1 V1 raised to gamma into V1 raised to minus gamma into V1 divided by minus gamma plus 1. So we will be getting V2 raised to plus gamma into V2 raised to minus gamma. Both that V2s will be cancelled. Similarly, in the second bracket, the V1 raised to gamma, V1 raised to minus gamma, both these terms will be cancelled, and finally you will be getting this type of the answers upon rearranging the terms. That is, work done W is equal to P1 V1 minus P2 V2 upon gamma minus 1. Dear friends, understand the steps perfectly. What I am explaining, calculate at your level, substituting the terms, rearrange the terms, and get the answer which I have highlighted of the work done. So if you have got the answer of the work done, kindly give me the confirmation in the chat box. If you have perfectly understood the answer for the work done, that is W is equal to P1 V1 minus P2 V2 upon gamma minus 1. Okay, so now we are already aware that PV is equal to MRT. So I can write down P1 V1 is equal to MRT1 and P2 V2 is equal to MRT2. MR remains constant, so it is removed from the bracket. And finally, I am getting this answer. W is equal to MRT1 minus MRT2 upon gamma minus 1. Very easy to understand. P1 V1 MRT1, P2 V2 MRT2. PV is equal to MRT. Proceeding further, now let us make the derivation between the pressure, volume and temperature. Again, it is a very simple derivation. Try to understand the steps. We are knowing that PV raised to gamma is equal to constant adiabatic law. And we are knowing the combined gas law, that is PV by T is equal to constant. Dividing both these equations, we are getting this form of the equation. Pressure remains constant, so it is cancelled it out from the denominator and the numerator. Transferring the T on the above side, we are getting this answer, that is T into V raised to gamma minus 1 is equal to constant. So if I am writing this equation considering the initial and the final states 1 and 2, I can write down T1 by T2 is equal to V2 by V1 raised to gamma minus 1. Dear students, I hope you are understanding these steps. It is very simple steps, just a simple mathematics and logics we are using for deriving the derivations and the relationships. Okay, fine. So now this is the relationship between temperature and volume. Let us proceed further in this derivation. We are already knowing the relationship between pressure and volume. Standard adiabatic law, that is P1 V1 raised to gamma is equal to P2 V2 raised to gamma. Now taking volume on one side and pressure on another side, I can write down V2 by V1 raised to gamma is equal to P1 by P2. Removing the term raised to gamma, transferring it on other side, I can write down V2 by V1 is equal to P1 by P2 raised to 1 by gamma. Substituting this value of V2 by V1, that is equal to P1 by P2 raised to 1 by gamma in equation number 1. Substituting this value in equation number 1, finally I will be getting the relationship between the temperature and pressure, that is T1 by T2 is equal to P1 by P2 raised to gamma minus 1 divided by gamma. I hope you have understood up till this point and you have got the answers of the derivation. Very easy friends, just focus on the equations and try to remember these steps so that you will be perfectly understanding the logics behind it and you will never forget the relations, because all these relations we will be using when we are going to solve the numericals. So let us proceed further. The change in internal energy, we have already remembered the equation, that is delta U is equal to mCv T2 minus T1. According to the first law of thermodynamics, Q is equal to delta U plus W. But in adiabatic process, Q is equal to 0. So I can write down delta U is equal to minus W. Next is the amount of heat transfer. According to the definition of adiabatic process, we can note down Q is equal to 0. There is no heat interaction. And the final equation, that is the change in enthalpy, standard equation of delta H, that is mCp T2 minus T1. Dear friends, dear students, we are already aware and we have already derived these equations in the previous topics of the non-flow processes, so no need to revise again and again. Delta U is equal to mCv T2 minus T1 and delta H is equal to mCp T2 minus T1. I hope the concepts are clear. So with this we are completing the adiabatic process. Now let us proceed further to the last process, that is the polytropic process. Remember friends, the polytropic process is the most commonly used process in the practical purposes for determining the properties of the gases. The standard equation for the adiabatic process is given as PV raised to N is equal to constant, where N represents the polytropic index. The value of N varies from minus infinity to plus infinity. But for practical purposes, the value of index N lies within the range of 1 to 1.7. And this is the PV diagram representing the polytropic process. See students, here we are noting down the equation, that is PV raised to N is equal to constant. The shaded portion represents the area of the diagram, that also represents the amount of the work. Proceeding further, that is a very important figure in context of the polytropic process. All those four processes which we have studied already, that all the four processes can be derived from the polytropic process. The standard equation for the polytropic process, that is PV raised to N is equal to constant. If we are substituting N is equal to infinity, then we will be getting the answer V raised to infinity, and any term raised to infinity, that is always a constant term. So when N is equal to infinity, we are getting the answer V is equal to constant, so that represents the constant volume process. Now substituting N is equal to 0, so PV raised to 0, that is equal to 1, V raised to 0, that is equal to 1, so we are getting the answer, that is P is equal to constant, so it represents the constant pressure process. Substituting N is equal to 1, we are getting the answer PV is equal to constant, so that represents the Boyle's law. And Boyle's law we have already understood, it can be applied to the constant temperature process, that is the N is equal to 1 isothermal process or the hyperbolic process. And if we are substituting N is equal to gamma, then we will be getting the answer PV raised to gamma is equal to constant. So that represents the adiabatic process. So that is shown in the figure. And other values of N, that is N is equal to N polytropic and N is equal to 1.2, that is again the polytropic process. So all the different non-flow processes can easily be derived from the polytropic process by just substituting the different values of the polytropic index. Proceeding further, the amount of the work done. Now friends, remember the point, the polytropic process is very similar to the adiabatic process. Only the change will be in the adiabatic process we are mentioning gamma, that is the adiabatic index. But in the polytropic process, now we will be mentioning N, that is the polytropic index. So replacing the gamma by N. So the work done, standard relation, integrating between the limits V1 and V2, PV raised to n is equal to constant, polytropic law, standard equation. So the same procedure as we have done in the adiabatic process, the same we can follow in the polytropic process. Only in the adiabatic here there was gamma, in polytropic it is small n. Doing that same procedure, following that same steps, finally we will be getting the answer. W is equal to P1V1 minus P2V2 upon n minus 1. Also we can write down W is equal to MRT1 minus MRT2 upon n minus 1. In adiabatic, here there was gamma. In polytropic, there will be small n. Moving further, the relationship between pressure, volume, temperature. The standard equation, that is PV raised to n is equal to constant. So I can write down P1V1 raised to n is equal to P2V2 raised to n. Also the relationship between temperature and pressure, that is T1 by T2 is equal to P1 by P2 raised to n minus 1 divided by n. Just we need to substitute the gamma, remove gamma and put the value of small n. So now the equations becomes related to the polytropic process. Dear friends, if you are understanding the simple points, then you can easily remember the equations. Relation between temperature and volume, that is T1 by T2 is equal to V2 by V1 raised to n minus 1. Change in internal energy, our standard relation, that is delta U is equal to mCV T2 minus T1. Also the change in enthalpy, again our standard relation, that is delta H is equal to mCp T2 minus T1. So these are the different equations, relationships in context of the polytropic process. Now friends, remember it is very similar to the adiabatic process, but in adiabatic process the heat transfer Q was equal to 0, but in polytropic process the heat transfer is not equal to 0. So now we will derive the equation for the amount of the heat transfer. So try to understand the steps of this derivation. According to the first law of thermodynamics, we can easily write down heat transfer is equal to work done plus change in internal energy. So Q is equal to W plus delta U. Substituting the value of W, that is P1V1 minus P2V2 upon n minus 1, and delta U is equal to mCV T2 minus T1. Now substituting CV is equal to R upon gamma minus 1. How we will be getting this relation? By using two equations. Cp minus Cv is equal to capital R and Cp by Cv is equal to gamma. If you are replacing the value of Cp by Cv and doing the mathematical steps, you will be getting the answer of Cv, that is equal to R upon gamma minus 1. So substituting this value of Cv in this equation, so you will be getting the answer plus mRT2 minus T1. So mRT2, that is equal to P2V2. mRT1, that is equal to P1V1 divided by gamma minus 1. Taking the negative sign outside, so in this also you will be getting the answer, that is minus P1V1 minus P2V2 upon gamma minus 1. Taking the term P1V1 minus P2V2 common throughout, so in bracket we will be getting the answer 1 upon n minus 1 minus 1 upon gamma minus 1. Doing the mathematical calculations, finally you will be getting this answer, that is Q is equal to gamma minus n upon gamma minus 1 into P1V1 minus P2V2 upon n minus 1. Dear friends, slowly and steadily understand these steps, substitute the values perfectly, do the mathematical calculations and try to get this answer of Q. Q is equal to gamma minus n upon gamma minus 1 into the bracket P1V1 minus P2V2 upon gamma n minus 1. If you are getting this answer, kindly give me your confirmation in the chat box. If you are understanding these steps, Okay, I have already receiving the responses from the students. Okay, fine. So now friends, if you remember this P1 V1 minus P2 V2 upon N minus 1, that is nothing but equal to W. So I can write down finally this equation. Q is equal to gamma minus N upon gamma minus 1 into W. This whole term in the bracket that represents W. We have used the same equation previously. So Q is equal to gamma minus N upon gamma minus 1 into W. So friends, with this, I am completing the session from my side. Thank you for watching the session. See you in the next lecture. And dear students, remember, with this I am completing the theoretical analytical concepts of the chapter of the properties of gases. From the next lecture onwards, we are going to solve the numericals of this chapter. So I suggest that you all must have the scientific calculators with you, because I will be asking you the calculations, the answers which you are getting, so that all the students need to calculate the numericals at your level, and I will be asking you the answers. So in the next lecture, we are going to solve the numericals of this chapter. So friends, with this I am concluding the session from my side. Thank you for watching the session. See you in the next lecture. Have a nice day. Now if you are having any questions related to the topics covered in today's session, then you can ask me. Otherwise, then I can close the meeting. Any doubts from your side, any student? Polytropic process, rule number 12, it is very easy process. Just remember the equation PV raised to N is equal to constant. If we are substituting the different values of N, then we will be getting different non-flow processes. And for the equations for work done, PVT, delta U and delta H, just replace gamma with the polytropic index N. And finally, the equation for the amount of heat transfer, that is Q is equal to gamma minus N upon gamma minus 1 into W. You just refer the points in the book, and still if you are having the confusion, then you can ask me. Rule number 12, I hope I have answered your doubt. Okay, fine. So with this, I am concluding the session. Thank you all.